Hello guys, welcome to another problem solving session with Special Maths Academy. My name is Ukome Jaife and today we're solving problem 2 of the 2022 second round exam, second round problem, and it says that in the figure below, the circle meets the size of an equilateral triangle at 6 points. You can see the points. I think the points are E, D, H, K, G, and F. Then we have that if A is equals to 2, ED is 13, DC is 1, and GF is 7. So we have to like find the length of HK, which is this. Okay, let me use the length of this red segment is what we're looking for. Okay, so the triangle is equilateral, so it means each of these angles is like 60 degrees as well. This is not something we want to forget. Okay, so to proceed here, I think we'll need this power of a point theorem. So I'm going to show something how. Supposing you have this okay, supposing you have a point, let's say a point P, Q, R, S, T. Then you have like PT and they are like QT and ROT, they meet at this. So we know that this is like QRS is a cyclic quadrilateral, right? So we know that if this is angle S, this is like 180 minus S, and this is also angle S, right? So this and this, yeah, equal. Similarly, if here is like this is T, so we know this is 180 minus T. I'm sure the reason this is because in a cyclic quadrilateral opposite angles are like supplementary. This is like T. So we have that these two are also, the ones in green are also equal. So you can see that, and this angle P is common to like both triangles. So you can see that triangle PQR is kind of like similar to triangle PST. You can just check this, right? So PQR is kind of similar to the like bigger ones. So we have something like PQ over, if you write out the ratios of similarities, equals to QRO over ST, PRO over PT. So we have that PQ. Then if I take this is not like the main, this is not like the problem. I'm just going to use this to solve the problem. So okay, rather this is PT. So if I cross multiply, I have something like PQ times PT equals PRO times PS, right? So it means PQ times PT. And you can see that Q and T are collinear. So PQ times PT equals PRO times PS. So we'll call this the power of the points theorem. And we're going to use that a lot here. So just keep in mind. So I'm going to clean this now because it's not actually part of the problem. I just wanted to show something. Okay. Just wanted to show what's like an identity we're going to be using that proves something useful. Because we're going to need that a lot in this problem. Power of a point. So let's go. Okay, so from power of a point, you can see that F and G are collinear. So first of all, know that F, G, A, D are on a circle. Sorry. So they are like, and you can see that BF intersection CE is something like, okay, yeah, equals to A. So you can think of A as that point P in our initial diagram. So I can use that. So if I use it from power of a point, I know that AF times AFS times AG, which is from the length from F and G on the same circle, AF times AG has to be equals to AE times AD. So I don't know AF. I can say let AF be equals to X. So this means X times AG is X plus 7. Because if this is X, then the whole stuff from A to G is like X plus 7. So I think this makes sense. Equals to A is 2. Then we can see that AD, this is AD. AD is 2 plus 13 is AE plus ED. That is 2 times 15, right? So that's something like X squared plus 7X equals 30. And that means X squared plus 7X minus 30 equals 0. And you can factorize this is X plus 10. X minus 3 equals 0. You know X is a length, so X, that means X is minus 10 or X is 3. So X is a length, so X cannot be negative, so it means X is 3. So it means that AF is equals to 3, right? So this is 3, this is 10. So we know that the triangle is equilateral, so this means that 3 plus 7 is 10, and we know that AB has to be equals to AC equals to BC because of the equilateral condition, right? Equilateral. And we know AC is like 2 plus 3 plus this thing plus 1, which is like 16. So I just plug in here. So it means AB. I know that AB is like already this. AB is consisting of 3 segments. 1, 2, and 3. I know that 3 plus 7 is 10. So we have that AB is something like 10 plus BG. And this is equals to like 16. Because AC is 16. So it means only BG is 6. So it means BG is 6 here. So it means here is 6. Wow. Okay, so far so good. We are proceeding. So we are not yet done. We still need to find HK. So how do we go about that to be a good question? So a reasonable way to move would still looking like power of a point once again. So we can call HK. Let's call the length of HK M. Then from power of a point, we're going to use power of a point like multiple times now. A lot, because I think we are going to need that a lot to finish up here. So I'm cleaning this because we don't need that anymore. So I'm going to clean those particles. I said let HK, the one we're looking for, be equals to M, right? Then from power of a point, this time we're going to go with respect to C now. With respect to C, we know that CD times CE, D and E are collinear, so you should know the CD, the first one times CE is CK times CH. CD is 1, CE is like 14, this entire length. Okay, I have to show you where CD is. CE, so CE is 1 plus 13, which is like 14. This is 14. And we don't know what CK is, but we know that CH is CK plus M. So we have 14 into CK plus M. Okay, so we can say, okay, that's 14 over CK equals CK plus M. I don't know how this will help. I'm just checking stuff out. Then I also know from power of a point with respect to B. Okay, this I'm going to take from point B now. I know that BG times BF has to be equals to BH times BK. So BG is 6, BF is 7, is 6 plus 7. So you can see BF here. So we know we got BG as 6, so BF is 13. So this is 6 times 13 because BH into BK is BH plus M, right? Okay. So we have that 6 times 13, and this is 78 into BH plus M, right? And we have that 14 is equals to CK into CK plus M. Okay, then we know that we also know that BH, we know from here to here, which is BH plus HK plus CK has to be equals to 16. HK is M, so we have that BH plus CK plus M is equals to 16. Okay, so are you seeing what I'm saying? Okay, so I'm thinking something like this could work. Okay, so I could just write this BH plus CK. I can write this as 16 minus M, right? And let's call this equation 1 and equation 2, right? So I can say equation, let's write this in full. Let's try seeing how we could, well, the aim is to find M. We said equation 1 is 78 equals, equation 1 have that 78 is equals to BH squared plus BHM when I expand, right? Equation 2, 14 equals CK squared plus CK dot M. So I can subtract both. I can do equation 1 minus 2. So I have something like 78 minus 14 equals BH squared plus BH dot M. Okay, minus CK squared plus CK dot M. I'm just subtracting. So this is 64. If you like, this is now having BH squared minus CH squared. Then the remaining one is M. If you expand, you have BH minus C. Okay, let me see. Okay, BH minus CK. Okay, this is BH minus CK too. This is not CH, this is BH minus CK square. Yeah. So and I can write this as BH minus CK. These parts I can use difference of two squares here to BH minus CK. Okay, subtract and plus. Then I can bring this out, BH minus CK. So I'll have just this. So I have BH plus CK plus M. Then you recall that BH plus CK plus M was like the entire length, which is 16. So all this is equals to 16. So I have 64 equals to BH minus CK times 16. So divide both sides by 4. I have that 60. I have BH minus CK is equals to 4. Okay, so far so good. So I have what BH minus CK is now. It's 4. And I have BH plus CK is 16 minus M. Okay, how useful is this? Let's find out. Okay, so I can write any other extra information this can give us. Let's still observe. Okay, so we have what BH plus BH minus CK is now. They are like 4. Okay, let's see. The triangle is still equilateral. That's one thing we should keep in mind. Okay, I think one way of going about this though could be okay. We have this. Okay, we could try solving simultaneously though. We could add this. If we had to have 2BH is 16 minus m plus 4, which is 20 minus m. We'll have BH as 20 minus m over 2, right? Yeah. So we have what BH is 20 minus m over 2. So we could then come here. Then you can recall that from this we had that 78 is from power of a point that we had 78 is BH into BH plus m, right? So I can just plug in values now. So I have 78 is 20 minus m over 2. This is the value of BH into 20 minus m over 2 plus m. Then this means that after I expand and do all this, so this is 20 minus m over 2 into 20 plus m over 2. So I cross multiply. So I have 78 times 4 equals 400 minus m squared. When you expand, you have this. This is 32, 312. And then I have m squared as 400 minus 312. M squared is 8. Yeah. So only m will now be square root of 88. Wow. So, and this is like 4 times 22, which is 2 root 22. So our m was to find hk before. So we have that hk is equals to m is equals to 2 root 22. And with that, we come to the end of this problem solving session. Wow. So it was actually a length chasing problem. So the main thing we did was to use power of a point, which we established by similar triangles. Then after that, we used power of a point. Then we chased and manipulated and used equilateral triangle properties, and just like that. Okay, then we solved a small system of equations at the end, and that was how we solved the problem. So with that, we've come to the end of this problem solving session. So still stick around. There are still more problems to be solved. Still Obukume Jaife, and I look